You've got about 15 seconds, not to finish this sentence, to actually survive. Because in space, there's no slow countdown, no dramatic last words. Your blood starts boiling before you even lose consciousness. And that's not even the worst way to go. Today, we're ranking every real, scientifically documented way space can kill you, from the ones that take 15 seconds to the ones that take 15 quintillion years. 1. Explosive decompression. If your suit tears open in space, you don't explode. That's the movie version, and it's wrong. Here's what actually happens. Your body is used to Earth's air pressing on it from every direction, about 14.7 pounds per square inch. In the vacuum of space, that pressure is zero. Nothing pressing back. And gas always moves from high pressure to low pressure. That's not opinion. That's physics. So the gas dissolved in your blood, the same stuff that makes a soda fizz when you crack it open, starts turning into bubbles inside your veins. In real documented cases of accidental depressurization, like a 1966 NASA test where a technician's suit failed at high altitude, the person remained conscious for about 14 seconds before passing out. Not because of blood boiling, but because their lungs pushed all the air out of them in under a second, and blood stopped carrying oxygen to the brain almost instantly. Here's the part that should genuinely surprise you. You'd have around 90 seconds before permanent damage sets in. If someone got you back to pressure in that window, you could survive completely intact. Space doesn't kill you instantly. It just doesn't forgive mistakes.
But suppose your suit doesn't fail. Suppose everything works perfectly, and the danger comes from something you can't feel, can't see, and is passing through your body right now. 2. Radiation. On Earth, you're wrapped in two invisible force fields, the atmosphere and the magnetosphere, blocking the majority of the universe's radiation before it ever reaches your skin. In deep space, that shield is gone. Astronauts on the International Space Station, which is still technically inside Earth's magnetic bubble, absorb about 10 times more radiation than people on the ground. That's manageable for a 6-month mission. But send someone to Mars, a roughly 9-month one-way trip with no magnetic protection at all, and the math changes fast. A large solar flare, the kind our sun produces every few years, could deliver a lethal radiation dose to an unshielded astronaut in under an hour. Not cancer 20 years later, radiation sickness within days. And here's the comparison that should actually stick with you. A single trip to Mars would expose an astronaut to roughly the radiation equivalent of a full-body CT scan every 5 days, for the length of the entire mission. This is the reason Mars mission designs increasingly involve giant water tanks or even human waste storage lining the walls of the spacecraft, because it turns out one of the best radiation shields we have is just mass, and water is heavy, cheap, and already coming with you.
Radiation is slow and invisible, but some threats in space are the exact opposite: fast, physical, and small enough to be almost impossible to see coming in.
There's a chunk of rock the size of a grain of sand currently orbiting Earth at around 17,000 miles per hour. At that speed, mass barely matters. Velocity does all the work. A micrometeoroid that weighs less than a paperclip carries roughly the same kinetic energy as a bowling ball dropped from a rooftop, except it's arriving 40 times faster than a rifle bullet.
This isn't hypothetical. In 2021, a micrometeoroid struck the ISS's Canadarm2 robotic arm and punched straight through it, leaving a hole large enough to see daylight through, in solid engineered aerospace hardware designed to withstand exactly this. The arm still worked. A spacesuit would not have been so lucky. NASA actually tracks over 27,000 pieces of debris larger than a softball and millions of smaller untracked fragments constantly. The ISS performs collision avoidance maneuvers, actual engine burns to dodge debris several times a year. So far, every way we've covered can kill a human body, But zoom out far enough, and space has threats that don't care about bodies at all, because they're not aimed at you. They're aimed at everything. 4. A rogue planet. Not every planet has a star. Astronomers estimate there could be billions of rogue planets wandering our galaxy alone, untethered to any solar system, ejected long ago by gravitational chaos during their formation. They're completely dark, no starlight to reflect. You wouldn't see one coming with a telescope. You'd only detect it by the way its gravity briefly bends the light of something behind it, a phenomenon so rare it's only been confirmed a handful of times. If a rogue planet the size of Earth silently drifted through our solar system, its gravity alone could be enough to destabilize planetary orbits without ever touching anything. No impact, no collision, just gravity, quietly rearranging everything. The genuinely unsettling part? This has almost certainly already happened somewhere in the galaxy, and we would have absolutely no way of knowing in advance if it were heading toward us, until it was already far too close to do anything about it. A rogue planet is terrifying because it's silent, but there's something even quieter than that. Something that doesn't destroy you. It erases the very possibility that you were ever there. 5. The sun's death. Here's some good news first. You have about 5 billion years before this one matters. When our sun runs out of hydrogen fuel, it won't just fade out. It will swell into a red giant, expanding outward until its surface reaches roughly the orbit of Earth itself. Mercury and Venus will be swallowed outright. Earth's fate is actually debated by astrophysicists. Some models say we get consumed, others say Earth's orbit will have drifted just far enough out to survive as a scorched, lifeless rock. Either way, survive is generous. Long before the red giant phase even begins, in about 1 billion years, the sun will have grown just bright enough to boil away Earth's oceans entirely. We won't be around to see the dramatic ending. We'll have been cooked long before the finale.
The sun's death is slow, and it's ours. But there's a class of object in the universe so violent, it can end a star system in seconds. And it's not even the most feared object we're about to talk about.
6. Gamma-ray bursts. When a massive star collapses, or 2 neutron stars collide, it can release a gamma-ray burst, a focused beam of energy so powerful, it releases more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. These beams are narrow, like a lighthouse, not a blast in every direction, which means most of the galaxy is safe from any given one. The danger is entirely about whether you happen to be standing in the beam. If a gamma-ray burst pointed directly at Earth from within a few thousand light-years, it could strip away the ozone layer in seconds, flood the surface with radiation, and trigger a mass extinction. Some scientists believe this may have actually happened once already, roughly 440 million years ago, as a leading theory for the Ordovician extinction event that wiped out around 85% of marine species. And that brings us to the end. Not an ending like the others. An ending that doesn't just kill things. It removes the concept of things entirely. 7. Heat death of the universe. Every star eventually burns out. Every black hole eventually evaporates, a process called Hawking radiation, so slow that the smallest black holes still take longer than the current age of the universe to fully disappear. Eventually, given enough time, and we're talking roughly 10 to the 100 years, a number so large that writing out every zero would take longer than the current age of the universe, every star, every black hole, every scrap of usable energy in the cosmos will have been spent. What's left is called heat death, a universe at perfectly even temperature with no pockets of energy left to do anything. No chemistry, no light, no thought. Not an explosion, not a bang, just uniformity, stretching on forever. It's the strangest entry on this list because there's no event, no astronaut, no explosion, no scream. Just entropy, patiently finishing what it started at the Big Bang. So there it is, 15 seconds to 15 quintillion years. Every single one of these is real physics, not science fiction. Some have already happened to actual missions. One is currently provably going to happen to everything that exists. And somehow, none of that is the unsettling part. The unsettling part is this. With everything in the universe capable of ending you this many different ways, you're reading this from a small blue rock that's been quietly protected from all of it for 4 billion years straight. If that doesn't make you want to know how the rest of this universe works, I don't know what will. Subscribe, because next week we're going somewhere that makes the fastest entry on this list feel like a warning shot. We're falling into a black hole.